Okay, so lesson on standardising data. In front of you is the normal distribution curve. Just have a little think. You've got 4 questions on there. Pause the video and think about them. Right, this one here, what's the mean and standard deviation of this? Well, the mean is going to be the middle one value, which is 0. The standard deviation is just going to be 1. Yeah, just because of the way the data is. Okay. How much data lies within 1 standard deviation? You need to remember this, which is 68%. Top right is 3 standard deviations, which is quite almost all your data, remember, which is 99.7%, and 2 standard deviations is 96%. Right, this curve is almost like your perfect normal distribution curve. Okay, with a mean of 0 and your standard deviation of 1. If we're comparing data, we want all our normal distribution curves to look like this, and it's a lot easier to compare. Right, another question, have a think about this. The heights of women are normally distributed with a mean of 168 centimetres and a standard deviation of 7. Between what heights do 68% of the women, 96% of the women, and 99.7% of the women lie? Okay. Now, obviously, just use this as a standard deviation curve, but actually change the values. Okay, so my mean is going to be 168, so this one here is 168 in the middle. Okay, and a standard deviation of 7. Which means this one here is going to be 168 plus 7, which is 175. Plus 7 again to get another standard distribution, which is 182. Plus 7 again, 189. And going back the other way, you've got to subtract 7. So 168 minus 7 is 161. Minus 7 again is 154. Minus 7 again is 147. Now let's deal with the question. 68% of women. Alright, so that's going to be this one and that one. So 68% is going to be 161. So if I just write to 175. And 96%, which is actually going to be 2% of my standard deviation. So 2 standard deviations. Okay, which again is going to be 154 and 182. And my last bit, which is 99.7%, which is going to be all of it, not all of it, but 3 to 3, is 147 to 189. Here you go, there's your actual answers if you want it written neatly. Okay, right, now let's do an example. Yeah, it's your parents' evening, yeah, and your parents get results of 3 subjects. In maths, you get 60% of the test. Stats, you get 80%. And in further maths, you get 30%. The question is, are your parents going to be happy? So, are these good scores? Have a little think about it. Maybe pause the video. Now, these are different subjects. Clearly, further maths is the hardest subject. So, maybe 30% isn't that hard, that bad of a score. You know, and you might consider stats really to be an easier subject. So, maybe 80, even though it seems the highest. You might be lowest in the class with 80%. So we need to think about what measures can we do to compare these. Now, I'd go for the mean, okay? And I'd look at something to compare your spread. And with your mean, I'll do your standard deviation. If you wanted to choose your median, that's fine, but go with your interquartile range for your median. But let's talk about your mean. Now, also, it's important to say, if you scored lower than the mean, it doesn't mean you failed the test, because in a sense, all the tests in the world, if you do the mean of that test, half of your people will be below the scores, half will be above the scores. And there's more about tests. Anyway. So I do it, I work out the average of these scores, okay, and the average's deviation is how different is my score from the deviation. So now think about it. Now, obviously maths, you got below average. The other 2 you got above average. So sorry to say this, your maths scores are not as good as your stats and your further maths. Okay. But now you got to ask between your stats and your further maths, which one's better? You could say stats because you know you're 20 above the mean, yeah. Then again, with your further maths, maybe that 5 is so hard to get that 5 that it's like such a better score to do. So what we need to do is we actually have to work out your standard deviation. Okay, and you should be able to work out as previous lesson on this. Okay, and 10, 10, 5. But then what does that mean? Even that might be a bit more confusing. So what we like to do, we like to standardise these scores. So I get your deviation and you divide these by your standard deviation. Okay, and this gives you -1, your 2, and your 1. Now, what it tells you is how many standard deviations your score is away from the mean. Okay. Now, if you look at stats, yeah, your plus 10 is 2 standard deviations away from the mean, and your further maths is only 1 standard deviation away from the mean. So essentially, you actually did really well in stats. Yeah, if we go all the way back to the normal distribution curve, yeah, 2 standard deviations is 90. So you've got to halve that score to get 48. So being 2 standard deviations above the mean means that you're 48% above the mean as well, which is quite a good score. Okay, so you essentially did really well in stats, and good in further maths, and not good at maths. Okay, there's actually a formula you really need to know. In the previous example, I worked out the deviation and I divided by the standard deviation to get your standardised score. But to work out your deviation, do your actual score subtracted by the mean. Okay, this bottom formula is the one that you need to know. Okay, so make sure you write this down. Okay. I'll give you another question for you. Okay, it's a question you can do. You've got 3 subjects: English, Maths, and Polish. You've got your score. Okay, you've got your standard deviation and mean score. Can you please work out your standardised scores for each of these, and then tell me which ones did you do well in? I'll pause the video. Sometimes do this. Right, here you go. I like to do it as a table, but your deviation is your score take away from your mean score. Yeah. Your standard deviation you were given, so you've got to do deviation divided by your standard deviation, which gives you standardised scores. So because your maths is 2 standard deviations above the mean, yeah, that means you actually did really well in the maths scores. Yeah. Your Polish you did 1 standard deviation, which again you did do good. Yeah. Your English you did 0.1 standard deviations away from the mean. Now if you think about it, that's not really that far away from the mean. So I'd actually say it's probably on the mean. So in English, I wouldn't say you did good, I'd say you did bad. I'd say you probably did roughly about the average for the class. Okay, right. That's what you need to do at the moment. Okay, I'm going to explain a little bit more to know what's going on, but if you get all that, just do your textbook work. Right. So the extra bit of thing you really need to understand is what's going on here. So this is one graph here. Okay, that's like your perfect normal distribution. Okay, it's got your mean of 0. Yeah, your standard deviation is 1. Yeah. Now what we want to do is if we get all our data, so like let's say our math scores, our science scores, and our Polish scores, to all look like this first graph here, then it's a lot easier to compare. So the first thing we do is we subtract your score from the mean, okay, which actually brings this graph over so that both the graphs have the same mean, and then we divide it by the standard deviation, which means whatever my standard deviation is will come to 1. Okay, and if you look now, both graphs right, are exactly the same. That means that we can compare, which is so much easier to compare. Okay. Do the textbook. Hope you enjoyed the lesson.